Hello everyone, welcome to my SolidWorks Simulation channel. Today you will carry out the study of a wheel rim using the cyclic symmetric boundary conditions. So let's start our simulation study now. So first of all, download this one quarter model of a wheel rim and open it in SolidWorks. Our first step is to define an axis. So just go to the reference geometry and make a reference axis. From here, select this face. So we have defined or created a reference axis, that is axis 1. Now that is a prerequisite in order to define a cyclic symmetry. Now go to the simulations and start a new simulation study, and from study type select the static. Okay. Now define the material, that is aluminum alloy. Here you have to define the fixtures. So go to the fixtures and select the fixed geometry. From here, select the advanced options. Then select the cyclic symmetry. So you have to define the two faces. This is the first face and this purple one is the second face. Beside this, you have to select an axis. So select this axis. You can see the preview of this wheel rim by using this cyclic symmetry. Okay. Now we will define an velocity, angular velocity, that in terms of RPM. So go to the loads, and from here you have to select the centrifugal force. And change units to metric. Here you have to define this axis and change RPM to 500 RPM. So when this wheel rim moves with this speed or velocity, then a centrifugal force has to be generated or created. Okay. Now go to the mesh and create mesh. Then create a curvature based mesh. Okay. And wait until mesh is being generated. So mesh has been created now. You can see mesh is very dense. So it will take so much computational time. So please reduce the mesh element size. Again go to the create mesh. And from here is the mesh element size. This one, just increase it to 50. Okay. So mesh is being pre-generated now. Here you can see the mesh is less dense with greater number of element size. Now you have to run the simulations. Oh, there is a problem that model is not stable because we have not restrained this model. So first, before going to the run the simulations, you have to define our fixtures. Go to the fixed geometry, and here go to advanced options. Then we will apply the fixture on the cylindrical face. So select this face. That the moment is 0 there is no translational moment. Only there will be the moment that will be the along the circumference. Okay. Now run the simulation again. So mesh has been created now. Sorry, the solution has been generated now. You can see the maximum stress values. If you go to edit definitions and change the units to megapascal, you can see that maximum stress value is 2.7 megapascal, while the yield strength of the material is 27.5 megapascal. So that means our wheel rim is safe. You can also check the factor of safety. Use one measure stress criteria. Okay. So factor of safety is 10. You can also plot the symmetric results for stress. So go to edit definitions. Then from the advanced options, display the symmetric results. Here you can see the symmetric values of these simulations. Now we want to check the deformation. So this is the deformation, total deformations. We want to check the deformations in another way. So go to the displacement plot. Here you have to check the deformation. Next directions. In x-z direction, that is very small. That is about 0.004. And if you check the deformation in the y direction, that is 0.0024. And we check the deformation in the z direction. That is almost same as that of the deformation in y directions. We can check, we can plot the symmetric results. Go to the advanced options and display the symmetric results. Here you can see the deformation about x about z directions. Just animate in order to check the behavior under this 500 RPM load. So I hope you enjoyed this simulation tutorial. Please make a practice of this. Thank you for watching.